Hello, this is Sonu. Welcome to the AWS session. In today's session, we are going to discuss about the AWS Lambda, how we can create and deploy the AWS Lambda services using the SAM CLI. For that, first we are starting with the SAM CLI installation. So let us open the browser and search for the SAM CLI setup. We can download and install the SAM CLI to the local machine. So let me search for SAM CLI, and you will be getting the SAM CLI setup from the AWS documentation website. So you will get the download link for Linux, Windows and Mac operating systems. Since I'm using Windows machine, I'm using this Windows setup. For running this SAM CLI, you need to have a valid AWS account, and you need to create the AWS credentials locally using the AWS configure command. And optionally, you can install the Docker for locally testing your SAM application, or if you want to deploy your application as a Docker container, you need the Docker in your local machine. But still, it is an optional step. So we can go to the fourth step, which is the SAM CLI download and install. Since I'm using Windows, I'm downloading the 64-bit version of this SAM CLI. The download will take a couple of minutes, depends on your internet speed. Now you can run the setup. This installation may take a couple of minutes to complete the installation. Since I have the SAM CLI already installed, you can see I'll get the change, repair or remove installation option. Since I have this SAM CLI latest version running in my machine, I'm cancelling this installation. So after the SAM CLI is successfully installed in your machine, you can verify the SAM installation by opening a command prompt and run the SAM version command. This will show you the installed SAM version. You can see in my machine, I have the version 1.57.0 is installed. So since I have the AWS credentials already configured in my machine, I can directly start creating a SAM application. For creating a SAM application, I want to create a folder. Inside the folder, I want to create all the demos. So let me go to the desktop, and I can create a folder. So I have created a folder called AWS SAM apps, and let me go inside this folder, and I can create a new SAM CLI application. So for creating a new SAM CLI application, I can use the SAM init command. When you run this SAM init command, it will prompt two options. You can either start with a quick start template, or you can bring your own custom template by specifying the custom template location. So I want to go with the default templates, or these quick start templates which is already available. So I'll choose the one, and these are the quick start templates already available. So we can start with a hello world simple example, or a multi-step workflow, or serverless API, or some other options you can see. But I want to create a serverless API, I want to create a RESTful service with DynamoDB, I want to choose the option 3, which is the serverless API. So once I select this option 3, it asks for the runtime version. We can create the Lambda applications either using .NET or .NET 6 or .NET 3.1 or Node.js or Python or some other languages. The SAM CLI currently support two languages, that is JavaScript and the .NET, that means C#. So I want to create the SAM CLI application using the latest .NET 6. So I go with the option 1. So it's asked to enable the X-ray tracing. So if you want to collect the telemetry from your application and send to the AWS X-ray for tracing and troubleshooting your application, or for monitoring the performance of your application, you can choose this option. But I don't want to enable this X-ray, so I just specify no. I can specify the project name. So by default it comes SAM app, but I can optionally specify a different project name. So since I want to create a Tech Events API, so I give the project name as Tech Events API. You can see it's cloning that project template from internet, and it will take some time. As you can see, the template is been downloaded, and now I can start creating this SAM application. After the project has been created, I can open the project in Visual Studio Code. For that, let me go inside the project folder and then open the project in VS Code. Inside the Visual Studio Code, you can now see the project is open, and this is a .NET 6 project, and this project primarily contains a template.yml file. The template.yml file contains the resources that we want to create and deploy as part of the SAM deployment. So you can see here, primarily there are two resources need to be created. One is an AWS serverless function, that is your Lambda, and the second one is a DynamoDB table, which is AWS serverless simple table type. But it is possible that we can modify this table structure with specifying a partition key and sort key for your DynamoDB table. So we will do the configuration changes later. Let us first open the SRC folder, where you can see the controllers folder. Inside the controllers, you have this books controller, which is the default controller provided by the template. This controller contains the CRUD operations for getting, posting, deleting, and updating the books records into the DynamoDB table. You can also see the entities folder. Inside the entities, you can see the DynamoDB table class, that is book. So this book table is mapping to a DynamoDB table, and you can see the properties, that is a hash key which represents the partition key for your DynamoDB table, and the other known key attributes of this entity. We also have a repository. The repository interface contains all the CRUD operations methods for create, delete, update, and read. The implementation of this CRUD operations are defined inside the book repository, a concrete class. You can see the interface is implemented to the book repository class. So this book repository class injecting the DynamoDB context, which uses the object persistence model API for connecting to the DynamoDB database and perform the CRUD operations. You can also verify the program.cs, which contains the required services registered inside the builder.services property. So the dependency injection register the DynamoDB service, then a DynamoDB context, and also the books repository class. This configuration helps us to register the DynamoDB services inside our application so that we can consume the DynamoDB service directly from the controller or any other class defined as part of the project. You can also see the configurations, or you can also add the configurations into the app settings.json. Suppose if you want to specify the AWS region or the user profile or any other informations that needs to be read by this application, you can specify that inside the app settings.json. First, we are going to modify the DynamoDB table configuration. By default, the SAM CLI is creating a template that uses the simple table. A simple table is a DynamoDB table that uses only the hash key or primary key. But we want to create a different table, so we can give the resource name as DynamoDB table and the resource type as AWS DynamoDB and table. So you can see the documentation inside the AWS section. So you can see the type is defined as AWS DynamoDB table, and under the properties section we need to define the attributes as well as the key schema. So inside the properties we can specify the table name. So I want to specify the table name as tech events, and we can also specify the attribute definitions, and inside the attribute definitions I want to specify the attribute name and attribute type. So I can just copy this parameters. So here attribute name I can specify as the ID, which is a string type. I can also specify one more attribute, which is going to be the hash key will be the technology name. So I can specify technology as the attribute name, and that is also a string type. Also, we need to specify the key schema. There I need to specify the attribute types, which one is used as the range key and which one is used as the hash key. So I can specify the attribute name, the technology is used as the hash key, and then the ID is going to be the range key. And you can also specify the throughput, the provision throughput capacity. So the throughput capacity can be 5 or 10, whatever you want to allocate for your table. So I have updated my DynamoDB configuration. As you can see, the resource type I have specified as AWS DynamoDB table. The table name is going to be tech events, and attribute definitions. I have mentioned there are two attributes that I am using, ID and technology. Both are string types, and the key schema defines which is used as the hash key and which one is used as the range key. So as you can see, technology field is used as the hash key and ID field is used as the range key. After the table resource has been modified, we need to also update the Lambda configuration. Since you can see the type of the resource is defined as AWS serverless function, which refer the sample table configuration. Since we have updated the table configuration and now the table reference name is DynamoDB table, we need to use this name wherever the sample table is used. So we need to update inside the environment variable where the sample table is a environment variable name which refer to the DynamoDB table. Also we need to specify under the policies that table name is need to be the reference of DynamoDB table. Once that is completed, we can save those changes and go back to the command prompt, and then you can specify the SAM build command. The SAM build command is going to compile this application. You can see the SAM build command successfully compiled and built the application. Now we need to sync the changes which we have made locally with the AWS cloud. For that, we can execute the SAM sync command along with the stack name. The stack name is the CloudFormation stack name, so I can give tech events stack as the name and then run this command. So to continue with, we can press yes, and this will create all the required resources in the AWS cloud. You can see the build process has initiated and the CloudFormation stack is creating the resources in the cloud. We can also cross-check this in the AWS console. In your CloudFormation, you can see that tech event stack is, you can see the status as create in progress. And inside the DynamoDB console, we can see the tech events table is created, and also we can check the Lambda console. So Lambda console is not containing any function so far. So once the CloudFormation creation process is completed, we can continue building the application locally. We can see the CloudFormation is creating the Lambda function and the required resources in the AWS cloud. Now you can see the stack creation is succeeded and we can see all the resources in the AWS cloud. So we can see the tech event stack creation is completed and the table as well as the function is created in the AWS cloud. Now we can start building the Lambda API. So for that, I'm just removing the existing controller entity and the repository classes. So let me delete one by one. I'm just removing the controller, books entity, and these repositories. So inside this program.cs, you can see there is a book repository service registered. You can remove this. So now we need to build our tech event service. For that, okay, so we also need to remove this repositories. Okay, so now we are going to build this repository entity and the controllers for our tech events API. For that, I'm going to create a new class inside the entities and give the name as tech event.cs, and this is inside the namespace tech events API dot entities, and inside this namespace I can create a public class tech event. Inside this class, sorry, this is the tech event public class. Inside this I need to define all the properties. First of all, we can add a DynamoDB table attribute to the class. This attribute maps the class to the particular table tech events, because tech events is the name of the table that we have. So here is the table name tech events. So this class is mapping to the tech events, and inside this we have to define the DynamoDB hash key property. So I can define public string technology, and also I can define the DynamoDB range key for a ID. So public string ID get and set. I can also define all the other non-key attributes for this particular class. I can add the remaining non-key attributes. So I have the title, which is marked as a DynamoDB property. I have a start date, end date, organizer, speakers, which is a list type, and an audience profiles, which is also a list type. Now I need to create a repository class. So for this, inside the repositories, I'm going to create an interface tech event repository, and I can define the namespace tech events API dot repositories, and inside this I can create a public interface tech event repository, and this repository contains the methods that we need to implement for the CRUD operations with the DynamoDB. Here we have the methods for this tech event repository. So these methods are used for adding, updating, deleting, and reading this tech events table entities. Now we need to create a repository class which implements this particular interface. For that, I can create a new class inside the repositories folder, tech event repository, and define the namespace tech events API dot repositories. Inside this, I can create a class tech event repository which implements the iTech event repository interface, and I need to implement the methods one by one. But before that, I'm going to create a member variable for the DB context, DB context object. So I can define Dynamo DB context So this DynamoDB context need to be imported, and using the constructor I'm injecting this iDynamoDB context service public tech events repository and injecting the iDynamoDB context DB context, which I can assign to this DB variable. Now I need to implement this interface methods one by one. So the first method that I have is the add event. So the add event async method I can implement. First, I need to define it as a public method with an async keyword. Now we need to import this tech events model, that is entity. And inside this, we need to define the method underscore db dot save async, and then the type is tech event, and then specify the tech event object. So just add the await keyword in front of that, and then we can return this tech event object. The tech event object's ID we are going to insert explicitly using this method. So before inserting this object, we can set the ID, that is a sort key of this DynamoDB entity, which I can set as a GUID. I'm generating a new GUID and converting that into string and then inserting into this tech event object. Now we need to implement this get event method, which is used for loading a single tech event object. So here is the method that read the event object using this partition key and the sort key. Here the technology is our partition key and the ID is our sort key. We can use the load async method for loading the tech event object from the DynamoDB table using this partition key and the sort key. We can also implement the get all events async method, which is used for reading all the tech events using a scan method. The scan is used for reading all the entities or all the records from the DynamoDB table from all the partitions. So you can see the scan method returns a async search object, and then we are reading the records batch wise and adding to a list which returns the complete list of tech event objects. Now we can define the update method, which is used for updating the existing tech event record in the DynamoDB table. For that, we are passing the tech event object data which we need to update, and then using that partition key and the sort key, we are loading the existing object and then updating those values. We are updating the object which we read from the DynamoDB table with the values that we have passed through the argument. Once we copy all the values to the object, we can call the save method which update the object back to the DynamoDB table. Now we can define the delete event method, which is accepting the partition key and the sort key as arguments and delete the tech event object from the DynamoDB table using this partition key and the sort key. Now I can create the controller class. For that, I'm adding a new class to the controllers folder, that is tech events controller. Inside this, I can add the namespace first, namespace tech events API dot controllers. Inside this, I can define the class, public class tech events controller that inherit from controller base. We can import this controller base from the namespace microsoft.aspnetcore.mvc, and also we can add the API controller annotation on top of this with a route attribute that defines the API slash controller placeholder. So inside this, I can use the repository. For that, first I need to register this repository as a service inside the program.cs. So I go to this program.cs, and inside this services, I can also register this repository as a scoped service. I tech event repository then tech event repository. So now we have registered the tech event repository as a service, and this repository I can use inside my controller. So I need to declare a variable of type I tech event repository. So I need to import this interface, and through the constructor I'm going to inject this. This repository I'm assigning to this repo variable, repo equal to the repository. Then I can write the controller actions for my API. The first action which I'm writing is for adding a new tech event object to the DynamoDB table using a post action. Here is the post action, which is used for adding a new tech event object to the DynamoDB table. For that, we are passing the tech event object as an argument of the create event method, and then using the repository method, I'm adding this tech event. If the record is successfully added, we are returning a created, that is 201 status code along with the result object back to the user. If there is an exception, it returns a status code with a 500 status code. After this, I can add a method for reading a single tech event record from the DynamoDB table. So I have defined an HTTP GET method which accepts the technology as well as the ID as arguments, route parameters of this action, and this method is going to call the repository get event async method and pass the technology and ID as arguments. So if the result is returned, we will use the OK status to return the result, or else we return a not found result back to the user. In case of exceptions, we are returning a 500 status code back to the user. To return all the tech events, I can use another get method, which is calling the get all async action, which internally calls the repository's get all events async method, and that is returning all the tech event results to the result variable, and we are returning the result using an OK status back to the user. We can also define a put action for updating the tech events object. So here we are accepting the technology and ID as URL parameters of the put action, and a tech event object will be received from the request body. We will verify whether the tech event technology, that is, we are verifying the technology partition key value is matching with the technology value inside the tech event object, which we need to update, and also the ID value, which is the range value, is matching with the ID value inside the tech event object. If they are matching, we are updating this record by calling the repository method, and once the update operation is completed, we return the status code OK back to the user. If the partition key and the range key is not matching, we are returning the bad request back to the user. Finally, we need to implement the delete action. So the delete action accepts the partition key and sort key as URL parameters and call the repository's delete event method to delete the record. After the record is deleted, we returns no content status, that is 204, back to the user. We can now add the Swagger documentation to our Lambda API. For that, we need to add the swashbuckle.asp.NET Core package. For that, we can run the .NET add command along with the CS project file path. Because our CS project file is located inside the SRC folder, we need to provide the complete path of the CS project file and then specify the package space the package name, that is swashbuckle.asp.NET Core, along with the version. So once you install this package, you are ready with the Swagger documentation. Now we can go back to our application and then add the Swagger service to the program.cs file. So inside the builder.services, we need to add the Swagger gen. This Swagger service is registered, and inside this middleware, means inside the app object, we need to register a middleware. For that, we can register app.use Swagger, as well as we can specify app.use Swagger UI. Inside the Swagger UI, we can specify some configuration parameters where we can specify the c.swagger endpoint, and then Swagger endpoint you can specify as /swagger/v1/swagger.json, and also the name we can specify as v1. Also, we can specify the root prefix equal to string.empty. So, because we are calling the Swagger in the root endpoint or root URL, we can remove this app.mapget method. So I'm commenting this, and now we are ready with the Swagger documentation. Now we can build and test the API locally. For that, we can switch to the command prompt and run the SAM build command to compile and build the application. We need to wait for some time for this applications to complete the compilation process. Now the compilation process is completed and we can test the API locally by running the SAM local start API command. Now you can see the application started locally on port number 3000. Now we can invoke and make a request to this. I'm opening this URL in the browser. You can see it opens the Swagger UI. We have all the methods available inside the Swagger UI. Now I'm going to insert a new tech events object. So for that, I'm opening this post method and adding a new tech event object. So let's add some value to this one. I have provided some values for the technology field, title, start date, end date, organizer, and the speaker list, and also for the audience profile. So for ID, I have given a dummy value 0, which will be replaced by our repository method that insert a GUID for our range key. Now let me execute this. You can see the method returns a 201 status code which indicates success. So I can go back to the DynamoDB table and open the tech events table and check the table items. We can see there is one item inserted into this table. We have this complete records available. We can now also check the get event method where I can use the ID and the technology value. So I go back to the Swagger UI, call the get method where I can pass the technology value as cloud and the ID which I have recently inserted. You can see this method successfully returns the record. I can also try calling the get all method. So execute this get all action that returns the array of available records. So we have only one record in the table and it is returned as an array. So we have successfully tested the application locally. Now we need to build and deploy the application to the AWS. To deploy this application into the AWS cloud, I can use the SAM deploy command along with the guided parameters. With this guided parameter, it asks the stack name. So you need to specify the same stack name that we have used at the time of calling the SAM sync method. So I can use tech events -stack So you can also cross-check this stack name inside the AWS cloud. So you can go to the cloud formations dashboard, where you will see the stack name as tech events. Okay, this is the name of the stack. You can copy this and provide that value here. You can specify the AWS region. Default region is selected as AP South 1. So I want to go ahead with that. So press enter and confirm the changes before deploying. You need to confirm by saying yes, and allow the SAM CLI to create a role for this. Now you can also specify whether you need to disable the rollback operation, yes or no. So I'll say no. And this netcode web API serverless may not have authorization defined. Is it okay? I say yes. You can confirm this and save arguments to configuration file. You can say yes. And SAM configuration file name you can specify as samconfig.toml. Just confirm by entering this. And the default configuration environment is default. Just leave as it is and press enter. And now it is going to deploy your application to the AWS cloud. Once it verifies the changes, you need to confirm by pressing yes to update these changes to the cloud. Say yes and press enter. Now it is start updating the services that is there in the cloud. You can now see the deployment process is completed successfully. Now we can go back to the AWS Lambda dashboard to verify the deployment. So here you can see the tech events stack is deploying the function. And once you go inside the function, you can see it is already connected with the API gateway. Once you click on this API gateway, you will see the API gateway endpoint. So you can click on this particular endpoint. I'm just clicking on this. This loads the Swagger UI, and you can confirm whether the API endpoints are working successfully by calling this get method. So let's go to the get and try it out and execute, and you can see this returns the data successfully. So if I want to read this single record, you can also test the get method for returning a single record by providing the technology value as cloud and then the ID for it, and they execute. This is going to return the single record. So we can understand the API is successfully deployed with the AWS Lambda.